Good morning, everybody. My name is Ankita. Today, we are going to see how counting sort works. Counting sort is a linear non-comparison based sorting algorithm that works great for a specific range of values. It counts the number of occurrences of each distinct elements in an array and uses that information to determine the sorted order of the array given. The count is sorted in an auxiliary array, and the sorting is done by mapping the count as an index of the new auxiliary array. Now, let us take an example and see how counting sort works. Now, let us consider the following example. Now here is this unsorted array which is given to us as the question. Now let us try sorting this array. Now let us try sorting this problem. The first thing we'll have to do is take a variable called count and initialize the count of each element to be 0. Now we are initializing the count of each element to be 0 initially. Later on, we are going to change the count of each element according to the algorithm. So now, according to the algorithm, we'll start comparing the first element with the rest of the element and increment the count of this element if this element is greater, or increment the count of the other elements if each of these elements are greater. We'll see how it works. Now, let us consider 87 first and compare it with 65. Now, out of these two, 87 is greater, so we're incrementing the count of 87 to 1. From 0, we're incrementing it to 1. And now we're considering 87 and 56. Out of these two, again 87 is greater, so we are making count of 87 to be 2. And then compare 87 with 10. Again, 87 is greater. So make the count of 87 to be 3. So now the count of 87 is 3. And then 87 and 45 will be compared. Again, 87 is greater. So change the count to 4. So we are going to increment the count each time. Now, 87 and 20, 87 is greater. So change the count to 5. And 87 and 76, 87 is greater. So the count of 87 is 6. And now since we have reached the end of the array, we have got the position of 87, which is 6th position. That is in the array. The index 6 will have 87. So the position of 87 is in the 6th place of our new array. So the rest of the elements would remain to be 0. I mean, the count of each of these elements is 0 in the first iteration. So this iteration is I equals to 1. Now we are going to compare the second element with the rest of the elements. Let us start with 65 and 56. Out of these two, 65 is greater, so we are incrementing the count from 0 to 1. Then compare 65 and 10. 65 is greater, so the count becomes 2. 65 and 45, the count becomes 3 because 65 is greater than 45. So the count becomes 3. Now 65 and 20 is compared. 65 is greater, so count becomes 4. Now 65 and 76 is compared. Here 76 is greater than 65, so increment the count of 76. So now we have compared all the elements, and the rest of the elements will be 0 as it is. And this is our second iteration. Yep. Now we have sorted the position of 87 and 65. So we are not again comparing 87 and 65 with the other elements. We'll move on with the other elements. Now 56 is compared to 10 in the third iteration. 56 is greater, increment the count 1. 56 and 45, again 56 is greater, so the count becomes 2. 56 and 20, 56 is greater, so the count now becomes 3. And 56 and 76 is compared. Out of this, 76 is greater, so increment the count of 76 from 1 to 2. Rest are 0. This is our third iteration. Yes. Now we have the positions of 86, 65, and 56. Let us start with 10. 10 and 45 will be compared. 45 is greater, so increment the count of 45 to 1. 10 and 20 is compared. 20 is greater, so increment the count of 20. 10 and 76 is compared. 76 is greater, increment the count of 76 from 2 to 3. And this is our fourth iteration. This remains to be 0. Now we are comparing 45 and 20. 45 is greater, so increment the count. 45 and 76 is compared, out of which 76 is greater, so increment the count. And 20 remains as it is. That is, the count of 20 remains to be 1 itself. So this is our fifth iteration. And then we have one more iteration to now we have got the position of 45 as well. Now we are comparing 20 with 76, which is greater, 76 is greater. So we are incrementing the count of 76 to 5, and 20 remains as it is, which is 1. Now comparing 76, we have the same value. So this is our iteration number 6. Now if we start the iteration from I is equals to 0, it goes up to I is equals to n minus 2. That is, if it is 7, if the n value is 7, then the I loop runs from 0 to n minus 2, that is 0 to 5. Or if it starts from 1, it runs from 1, I is equals to 1 to I is equals to n minus 1, that is up to 6 iterations. So now we have the index of each of these elements that we have to place these elements in the new array. Now let's see how we have to do it. The index of the new array, let us take it to be 1, 0, 1, 2, 3, 4, 5, and 6. Now the count of 10 is 0. So we're placing 10 in the 0th index. The count of 20 is 1. So in the index 1, we are placing 20. Count of which element is 2? If we look for that, count of 45 is 2. So 45 will be placed at the index position 2. 3 we have 56. Fourth we have 65. In the fifth position we have 76. In the sixth position we have 87. So this is our new sorted array. So this is going to be our new sorted array. So this is how the counting sort algorithm basically works. Now let us see the algorithm step by step. So this is how the algorithm for counting sort looks like. Now initially we are taking a loop, for loop, in which I starts from 0 and it goes till n minus 1. So if we have n elements where n is equals to 7, now this loop runs from 0 to 6 and initializes the count of each of these elements to be 0, as we have already seen in the previous example. Now, this next loop runs from I is equals to 0 to n minus 2. That is from I is equals to 0 to n is 7, so n minus 2 will be 5. So it runs from 0 to 5. Now, let us get into the j loop, which is the inner loop, and j starts from I plus 1. Now, here in this iteration, I is 0. So j is the inner loop, which starts from I plus 1 to n minus 1. That is, if I is 0, j becomes, for this iteration, j becomes I plus 1. That is, it starts from 1 and goes up to the sixth element. That is n minus 1. 7 minus 1 is 6. So it starts from 1 and goes up to 6. And these conditions will be checked. And if they are met, that is, if the a of I is less than a of j, j count will be incremented. Else, I count will be incremented. Let's see this. So here for I, the index of 10th element will be compared to the rest of the elements. 10 is less than 20, so the count of 20 will be incremented to 1. Now here a of I is 10, a of j is 20. So now since 20 is greater, j will be incremented by 1. And then j gets incremented, now j becomes 2, then 10 and 5 will be checked, out of which 10 is greater. So the value of count of 10 will be 1. Then 10 and 56 is checked, out of which 56 is greater. So count of 56 becomes 1. And similarly, 86 is greater, 75 is again greater, and 3 is not greater, so 3 remains to be 0, and 5 also remains to be 0. 5 remains to be 0, and since this 3 was less than 10, we have to increment the count of 10 to 2. Right, yes. Now let us start. Now the I is incremented to 1, so this is first iteration. And here we are comparing 20 with the rest of the elements, and again the same thing continues. 20 is greater than 5, so increment I, that is our 20 should be incremented, that is 2. Now this remains to be 0 itself. 56 is greater than 20, so increment the count of 56. 86 is greater, so incrementing. 75 is greater than 20, so incrementing. But 3 is not greater than 20, so 3 becomes 0. And our 20's count will be incremented to 3. Now we are getting out of this inner loop and incrementing the I value to be 2. So now we have to check from 5 and the rest of the elements. So here 5 is less than 56. So the value of 56 will be incremented to 3. And 86 is greater than 56, so incrementing it to 3. 56 is greater, so 3. 86 is greater, so again 3. 75 is greater, 3 again. But 3 is not greater, so 3 remains. 3 remains to be 0, and we'll increment the value of 5 to 1. Because 3 was lesser and 5 was greater, we're incrementing 5 to be 1. Now again, we're exiting the loop and incrementing I value to 3. Now check from 56. Now 56 is less than 86, so incrementing the count of 86 to be 4. 75 is greater than 86, so that becomes 4 as well. 3 is less, so the count remains to be 0 then, and the count of 54 will be, the count of 56 will become 4 then. Again, this iteration is over. We're incrementing the value to be 4, I value to be 4, and from 86, we have to run this loop. 86 will be compared with 75. 86 is greater, so count goes from 4 to 5. 75 is done, so it remains 4, and 86 and 3 will be compared. Obviously, 86 is greater, so the count changes to 6. Now, the fifth iteration, we're going to check 75 and 3, out of which 75 is greater. So we will increment the count of 75 to 5, and 3 remains 0. Now, since all the iterations are done and we're exiting from this entire loop, we'll go to the next loop where I starts from 0 and it goes to n-1. And we are assigning the indexes of these value to the new array. That is, we've taken a new array from 0 to 6. And we also have the count values of these elements. And now we'll place these elements according to these count values as their indexes. That is what this loop is doing. So let's do that. In 0th position, we'll place 3 because the count of 3 is 0. Now, in 1's position, we'll place 5. As we see here, the count of 5 is 1. Then in 2's position, we are placing 10. In 3's position, we have 20. And in 4th position, we have 56. And in 5th position, we have 75. The last 6th position, which is our highest element, is 86. So as you can see now, the given array is sorted, and we did this only by counting the number of occurrences of each element. So this is what counting algorithm states. Now let us see the time complexity. The time complexity of counting sort algorithm is n square. And some real world applications of counting sort are frequency counting, histogram regeneration, image processing. Advantages of counting sort: stable sorting. That is, the counting sort does not reorder the elements. It makes sure that the order remains the same. That is why it is stable sorting. And non-comparison based. Unlike merge sort, quick sort, we do not compare the elements, so it saves up a lot of time. And the disadvantages of counting sort is it is limited to integers. That is, if we want to apply it for different data types, we'll have to modify the algorithm. So that is a limitation, and it is not in place. That is, it uses extra memory space, so hence it is not in place algorithm. So this was all about counting sort algorithm. Thank you.